Hello guys, welcome to the second lecture of the chapter Polynomials. If you haven't watched the first lecture, make sure that you watch the first lecture first and then come to the second lecture for better understanding. You can check it out in the playlist of this chapter. In the first lecture of the polynomials, we saw what is polynomial and classification of polynomial, and then we saw geometric meaning of zeros of a linear polynomial, and also we saw what is the meaning of zeros of a polynomial. Now going ahead in the chapter, let's see how to find the zeros of a quadratic polynomial graphically. So let's take the example of a quadratic polynomial x square minus 3x minus 4. So the steps and the procedures are same as that of finding the solution of a linear polynomial. That is, first you will take the equation and then equate the equation to y. Since we need two variables to draw a graph, so we have to equate it to a variable y, and then we have to get these points by putting a value of x and then getting the value of y. That's when we get the coordinate points, which we can plot it in the graph and get the graph. So in this equation we'll take x and y in a tabular column, and then we will put the value of x as minus 2. Put a value of x such as numbers like minus 2, minus 1, 0, 1, 2, not more than that, because the higher number you put, the more the complex the number will become. The higher the number will become in magnitude, and then you will have to stretch the graph to a large extent, which is not possible in a sheet of paper. So make sure that you put a small values like minus 2, minus 1, 0, 1 or 2 or 3, not more than that. Now we have put the value minus 2. So when we put the value of x as minus 2 in this equation, we will get the value of y as 6. For example, minus 2 square is 4. 4 minus 3 minus of 2 is 6. So 4 plus 6 is 10. 10 minus 4 is 6. So you get the value of y as 6. And when you put the value of x as minus 1, you get minus 1 square is 1. Minus 3 into 1 is minus 3. 1 minus 3 is minus 2. Sorry, minus 3, so it is plus 3. Minus into minus becomes plus, so it becomes plus 3. 1 plus 3 minus 4, which is equal to 0. That's how you will be getting all the points of y by putting the value of x, and then this pair becomes one pair of the coordinate point. This minus 2 comma 6 becomes one point in the coordinate plane, and then minus 1 comma 0 becomes another point in the coordinate graph plane. You can make note of these points, or you can take a screenshot of these points of this board, and then now if you plot these points graphically in this graph. Now in this board I have taken approximate distances. If you plot this in the graph paper, in the graph sheet, you will get it exactly, you will get a perfect graph without any error. So now if we join all these points, these are the points, guys. So minus 2 comma 6 is here, minus 2 comma 6 is here, and then minus 1 comma 0 is here. This point is minus 1 comma 0, and 0 comma minus 4 is here, and then minus 1 comma minus 6 is here. In similar way you can plot all the points. I have already dotted all the points. Now what we'll be doing is we'll connect all these points. So here it didn't come so properly. So you will get the graph in the form of parabola. In a parabola, the graph touches the x-axis or intercepts the x-axis in 2 points. These are the 2 points, guys. It is minus 1 and 4. As you have learnt in the previous lecture, that the intercept of the equation of the graph in the x-axis gives us the 0 of the given polynomial. So minus 1 and 4 are the two zeros of the given polynomial x square minus 3x minus 4. In similar way, given any quadratic polynomial, finding the coordinate points of that equation of the given quadratic polynomial and then plotting it in the graph and looking for the intercept in the x-axis, you will clearly be able to find the zeros of the quadratic polynomial. So guys, as I said you, the highest number of zeros of any polynomial is equal to number of degree the polynomial has. For a linear it's 1, for a cubic it's 3, for a quadratic it's 2. As I said you, it's the utmost zero possible. There are cases, right? It can have at most, it can have at least, it can have no zero as well. So that's what we are going to see now. We are going to see all the possible cases taking an example of a quadratic polynomial. Let's take for example, there are three cases possible when it comes to a quadratic polynomial. That, as we saw, a graph of a quadratic polynomial is generally a parabola which is in a parabolic shape. So the three possible cases are, case 1 is that the parabola may intercept the x-axis in two distinct points, that is two different points, which means it will have two distinct zeros for the polynomial. This is one example, guys. This is one more example for case 1 in which the polynomial will have two zeros. Now let's go and see the case 2 in which the quadratic polynomial will have only one zero. It will actually have two zeros, but both the zeros are going to be the same number, which means it's also like a same number. I mean, it's like, for example, minus 2, 2, minus 2 and minus 2. These two are same numbers, but these two are the zeros of the polynomial. This is the second case possible. And the third case is that the quadratic polynomial may not have any zero possible. In that case, the graph won't cut the x-axis at all. It won't intercept or touch the x-axis at all. In the case of 1, 0, it will 1 and same 0 equal zeros. The graph will cut the x-axis at exactly one point. It's not cut, you may say that it may touch the x-axis in one point. These are the three possible cases for a quadratic polynomial. So first case is that two distinct zeros. Second case is that it may have 1, 0 which the graph touches the x-axis at that point. And the third case is that the quadratic equation may not have any zero for that equation. So guys, now after learning the geometric meaning of zeros of a linear and quadratic polynomial, let's go ahead and try to learn the zeros of a cubic polynomial as well. Let's take an example of a simple cubic polynomial x cube. The power of x is 3, which means the degree is 3, which means the polynomial is of degree 3, which means the polynomial is a cubic polynomial. This is a polynomial. Now we have to first equate this polynomial to y. So y will be equal to x cube. Now we have to plot the points. We have to put the values of x and get the values of y. That's when we get the coordinates to plot it in the graph. So in the tabular column, we'll put the values of x as minus 2, minus 1, 0, 1 and 2. We'll be putting 5 points, so we'll be getting 5 corresponding points of y corresponding to x. And then we'll be getting the coordinate as minus 2, minus 8 as the first coordinate. Minus 2, minus 8 is somewhere here. Minus 1 is here. 0, 0 is here. 0, 0 is here. 1, 1 is here. And 2, 8 is here. We have got the 5 points. So for what are you waiting? Let's connect the points. When you connect these points, this is the equation, graphical curve of this equation, y equal to x cube. Now, as you know, zeros of the polynomial are the points at which the graph, the equation, the curve intercepts the x-axis at. So this curve intercepts the x-axis at 0. If you'll be able to see here, this is the origin of the coordinate axis, which is 0. So the 0 of this quadratic polynomial is 0. The 0 of this quadratic polynomial is number 0. So you get only one point at which this curve intercepts the x-axis, which means for this equation it has only one solution or one zero of the polynomial. As I said to you, for a cubic polynomial, at most it can have 3 zeros. For this specific cubic equation, there's only one zero. So first of all, I would like to congratulate you guys. You have come this far in this chapter. We have finished 2.1 and 2.2 section of your NCERT textbook. That is, what are polynomials, what is the meaning of zeros of polynomial, and graphical meaning of zeros of polynomial. After mastering these topics, you are well-fledged ready to attempt exercise 2.1. Exercise 2.1 is very small, guys. It has only one question which has further divided into 6 sub-questions. Now we'll be solving the exercise 2.1. In exercise 2.1, I didn't write the question. You can see it in your textbook. The question is, you have to tell the number of zeros of the given polynomial equation. These are the equation of any polynomial. They are not given the polynomial, but they are given the equation curve. Seeing this equation curve from the graph, we have to tell how many zeros it has. You have to just tell the number of zeros. As you know, the number of zeros is the number of points at which the curve cuts the x-axis. So this curve cuts the x-axis at no point, which means number of zeros is 0. Now if you see, the second curve cuts the x-axis at exactly 1 point, which means the number of zeros for this curve or this polynomial equation is equal to 1. And now if you see the third part, this curve, yeah, can you tell me? It cuts the curve exactly at 2 points. Here and here it touches. So if it touches the x-axis, you will take it as 1. So it's 1 and 1, so it's 2. So this equation has 2 zeros, or yeah, it has 2 zeros for the curve, 2 zeros of the polynomial. If you see this parabolic curve, as you know, you would have guessed it, that it might be the equation of a quadratic curve, quadratic parabola, quadratic equation. So it intercepts the x-axis at 2 points, which means the curve, the polynomial will have 2 zeros of polynomial. If you see this graph, we'll find that it intercepts x-axis at 1, 2, 3, 4 points, which means it has 4 zeros. And if you see this curve, it intercepts at 1, it touches here and it touches here as well. So it's 1, 2 and 3. So it has 3 zeros of polynomial. I'll get aside so that you can take a screenshot of the slide. It's 0 here, it's 1 here, it's 2 here, it's 2 here again, it's 4, and it is 3. You can take the screenshot of the slide, guys.